Welcome back to another session on data structures and algorithms. So in this particular session, I am going to solve one problem from the LeetCode, and this particular problem is actually asked in all these 4 companies. So now let's go to LeetCode and see what exactly the problem is. So if I take you to the LeetCode, so the name of the problem is rotate image, problem number is 48 and the level of this question is medium. Now let's see what exactly the question reads. So you are given a n cross n matrix representing an image. So basically they are giving you a square matrix which represents an image. Next, rotate the image 90 degrees. So 90 degrees can be clockwise, anti-clockwise. They are saying it should be clockwise. So basically in this particular direction. Next, let's see the next paragraph. You have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not allocate another 2D matrix and do not do the rotation. So basically what they mean to say is, this is a particular input. So assume that this is an image and you have to rotate it 90 degree in the clockwise direction. So when you rotate this 90 degree in the clockwise direction, what exactly happens is, this 7 which is over here comes over here. This 4 which is over here would come over here. Next, which 1 over here would come over here. Sorry, over here. Now that and the same thing happens with all the elements. So this 1 will come over here, this 2 comes over here, this 3 comes over here. Same when 9 goes there. So that's what exactly happens. So and that is the output when you rotate it 90 degree toward in the clockwise direction. But one thing that they have told is, the most tricky part is that they are saying you're not supposed to create another matrix and do it. Rather what you have to do is, the modifications has to be done in the same matrix, which is bit complex thing to do. So first I would like you to create another matrix and then think about doing it and then do it in the same matrix. But the right output would be only when you do in the same matrix without creating another matrix. So how to approach? Let's just go and see how exactly can we do. So what I do is, I have taken another example over here which is slightly bigger than that particular example so that you get a better understanding. So if this is the input and if you rotate it 90 degree, this will be your output. Now how exactly can you fetch step by step? If you say it's something like this, let me pick all the elements in the 4 different corners. So if I highlight all of these elements, what exactly should happen is, the element present in this corner goes to that corner, this corner comes to this corner, and this corner element comes to this corner, and this corner comes to this corner. So basically it gets rotated, something like baseball where the one rotation completely happens. Next, if I pick the second element, this 2 gets replaced with 10 and the 10 with 24, 24 with 16 and 16 with 2. So again 4 elements gets replaced. Next, 3 with 15 and 15 with 23 and 23 with 11 and 11 with 3. Next, 4 with 20, then 20 with 22, 22 with 6 and 6 with 4. Now if you observe, the outer part of the matrix is actually rotated, and if you see the outer part of the matrix, it is as the expected output, but the inner part is not rotated. So maybe you need to start from here. So I think you are remembering a kind of logic which starts from here. Now 7 should replace with 9, 9 with 19, 19 with 17, 17 with 7. So I hope you are seeing some pattern over here. So I think if you take some 4 different values which is pointing over here and one pointing over here, one pointing to this column and one pointing to the last column, maybe you will be able to get a logic, and then maybe incrementing them, decrementing them, and some swapping. If you do, you will definitely be able to get an idea about how exactly this can be solved. Now I want you guys to just pause the video over here and then try to take a paper and pen, write down the logic, think about how this problem can be solved, and then you write the code by yourself. In case if you are not able to get the expected output, do not worry, debug the code and fix the problem. If you are still not able to fix the problem, come back and watch the video. I hope you were capable of solving this problem by yourself. In case if you had some small bugs and if you are then watching this video, no problem, that's really great. In case if you didn't even try and if you didn't even pause the video, that's very disappointing. Nothing to worry, let's continue with the problem. So this is the input and this should be the output for that particular thing. So basically if you rotate this, this should be the expected output. Now how can we solve this? Now if you have to solve this, all the videos which you had already which were available before this particular video on matrix, I'd expect you to watch those videos and then continue, because it has some correlation with the previous videos. How can it be done? Very simple. Now I hope you already know. I don't want you guys to actually create different variables. Let's see in the abstract level how it can be solved. So you already know few things like transpose a matrix. So what I'll do is, in case if this is the matrix, you know how to transpose this particular matrix by having a completely new matrix, and you even know how to transport within the matrix itself, and you have already written the code. In case if you have not watched that video, make sure you go and watch that video first. So if you transpose this particular matrix, this matrix will get converted something like this. So this is a transpose of this. Next, whatever you got as a result of the transposed matrix, this particular matrix, I would like you to actually reverse in the vertically. Means what exactly I want you to do? Keep a mirror over here and find the mirror image of that, and this one is also solved already. And if you find the mirror image, if you keep a mirror over here and find the mirror image, so the output of this particular matrix would look something like this. So basically first you transposed, then you did the reverse of the particular matrix. Now if you see the output actually matches with this particular output, and this is what? Nothing but rotation of 90-degree rotation in clockwise direction of the matrix. So if you do just transpose and reverse, which we have already studied, you will get the expected output. So this is all the logic is. So in case if you had actually spent time by creating 4 different variables, or left, right, bottom, left, and then swapping them, then maybe you did something more, or you thought in different lines, but that's also possible, but that's too much of hard work for your brain. Now I hope you already know the code for this. Let's go and see the code and execute in LeetCode, and then just see if you are getting the expected output or not. Now let's go and write the code. So in this LeetCode, they are actually expecting one particular matrix, they are accepting one matrix, and then you don't have to return anything, because whatever the matrix they have passed, it's nothing but call by reference, and whatever changes you do, it will be reflected from the main method itself. So before I write the code over here, I would like to write the code in my editor and then copy paste the code over here. So let me take you to my editor. So if I take you over here, I have already created one matrix, and then I am calling rotate AR, and I also have print matrix. Now what I would like to do is, I would like to call print matrix just to check if I am getting the expected output or not. So I will just print matrix first. So I will call print matrix before I rotate, and after that just one line gap I need. I will say system.out.println. No, immediately after calling print matrix I will put that. So I will put system.out.println over here. Great. Next I will rotate it. So this is just a dummy line. This is also a dummy line, just to see if I are getting the expected output. Next, after this, what I have to do is I have to rotate. So let me open this rotate. Now over here I will not write any code from scratch. I have already taught you how to do the transpose. So in this particular program, all that I need to do is first do the transpose and then do the reverse. So I will just first say over here, I will just comment one line and I will say transpose matrix. So I will say transpose matrix. Great. Next, after that I will do 2 lines of gap, and then I will say over after I transpose I need to reverse, so I will say reverse matrix. So I have told you the logic for transposing matrix as well as reversing logic. So for transposing logic, I will go to that particular class and then I will copy the code from there. So if you observe over here, I will return transpose. So if I just open the transpose, the line number 4, if I just open it, you can observe one thing over here. I have created a completely new array or the list over here. So it's a new matrix, but in question they have clearly told you are not supposed to create a new one. Then this logic will not work. I had shown you 2 different logics. So let me open the other one. So if I open the second one, over here if you observe, I have just done swapping and I have done the transpose. So I have not created a new matrix or a new 2-dimensional array over here. So this logic will work. So what I would like to do is, this is a generic code. So I will just copy the code which is there inside this. Then I will go to my actual class and I will paste this code. So transpose matrix I will paste it. So this is a code. Let's see if the namings are correct. It is AR, this is also AR, yes, totally fine. Next, what I need to do is, whatever I have been transposed, the same thing I need to reverse. So I am not calling a different method, rather I will write the method over here itself. So what I will do is, I will go to reverse matrix problem. So if I go to reverse matrix problem, over here I have written the logic for reverse matrix. Let me open that logic. So this is a logic for reversing a matrix. So I will copy the code which is there inside this. After that, I will go to this particular place and I will paste it. So this logic and this logic I have explained you in two different videos. In case if you have not watched that particular video, make sure that you go and watch the transpose of matrix as well as reversing of this matrix, and I have given assignments according to this as well. So make sure that you go and solve that particular assignments and then come and solve this particular problem. So now what I'd like to do is, I'll just like to come to the main method. The logic is actually done. All that I would like to do is just again print the matrix and check if I was successful in rotating it or not. So I will just call it the print matrix once again. That's it. So let's go and execute and see if we are getting the expected output. So if I execute the code, so this is a image and this is the rotated image. So let's see the corners first. So one which was here should have come to this place. Yes, it has come. One which the element 21 should have come to this place. So it has come over here. The 25 should have come to this place. So if you see 25 has actually come over here, and 5 should have come on top and it has come on top. And the same thing I want you to see. And 13 is which is there in the center. So it will definitely, even if you rotate it, will remain in the same place. It's remained in the same place. And towards its left was 8. It should have actually come here and it has come over here. So the best way to see whether it's working or not is very simple. Go and check in LeetCode. So what I would like to do is, I'd like to go to that particular method. So I will just copy the code that I have written inside this particular method. Yes. Then I will copy this and paste it in LeetCode. So if I take you to the LeetCode. So this is the LeetCode. So over here I'd like to paste it inside. Great. So I have written the code and whatever line has to be commented, it is commented as well. One thing is, I have written everywhere as AR instead of matrix. But what they are giving is matrix. So what you can do is, you can change everywhere wherever you are written from AR to matrix, or you directly change it over here naming as AR. So I will change over here because that's a lazy job to do. So I will change it. Great. First let's run and see if it's working or not. So I will go and run the code. So if I run the code, it's processing, accepted. Great. But I am not pretty sure like will it really accept all the test cases or not. So let's click on submit and then check whether it's accepting or not. So if I click on submit, so it's actually checking. So it has been accepted. So if okay, runtime 0 milliseconds, faster than 100% of the Java Online submissions for rotate image. So basically this stands on the top when it comes to runtime time complexity. So this as the best time complexity is what they are saying, and memory usage is 39.6, lesser than 11 point. So when it comes to memory usage, we have actually used more memory because while swapping and all, we have created a completely new variable. If you change the swapping method, then definitely the memory usage also will actually increase, it will reduce and it will be better than 11%. I hope this problem is completely clear to you guys. And if you had observed this problem, it was not very difficult. It was difficult if you had not taken a pen and paper and tried different combinations. Rather like how I explained at starting, taking 4 variables, rotating one by one. In that case, it would have been complex. But if you know already how to transpose and how to reverse, then this problem is damn easy. So that is what is all about coding interviews. Or you actually won't be knowing the exact question what might come in a coding interview. But if you practice so many different problems, in whatever comes in a coding interview, that might be a completely new problem. But you will be able to solve it by taking some logic from some other program, some part of the logic from some other program, and then mix it up, mix and match, you will be able to come up with the solution. So I hope this is completely clear to you guys, and I would always expect you to solve more and more problems. So I have picked one easy problem from LeetCode for you to solve. So this is the problem. So the name of the problem is flipping an image, and I am giving you easy problem, and the problem number is 832. I would expect you guys to go and read the problem statement and then write the code for this problem statement.